Sometimes shadows are sharper than reality. Picture a quiet room. On one side, a small focused bulb shines straight onto a ball. The shadow that forms on the wall behind is crisp, the edge almost as defined as the ball itself. Every contour stands out, as if drawn with a fine pencil. Now shift to a larger light, perhaps a broad lamp or a window on an overcast day. The same ball in the same position now casts a shadow with edges that blend into the light. The boundaries are gentle, fading, almost uncertain. The difference is striking with a small light source. Rays travel closely together, carving out sharp outlines. From a larger source, light approaches from many angles, so the shadow's edge is diluted, blurring its form. This is the geometry of light revealed in shadow. Step closer and examine the structure of these shadows. Shadows are not simply dark cutouts, they are composed of distinct regions. At the core is the umbra, where the object blocks all light from reaching the surface. Here the darkness is deepest, and the boundary most precise. Surrounding this core is the penumbra, a borderland where some, but not all, of the light is blocked. In the penumbra, the shadow softens, fading from the deep black of the umbra out toward the illuminated surface. The wider the light source, the greater the penumbra, expanding the gradient between full shadow and full light. Consider everyday moments: a tree's shadow at noon, its umbra crisp beneath the blazing sun, and its penumbra barely noticeable. At dawn or dusk, with the sun lower and its light spread wide, the penumbra stretches and the shadow's edge grows gentle and diffuse. Now let's shift the scene by moving the object. Imagine holding your hand above a table with a lamp shining from above. As you lower your hand closer to the surface, the shadow grows larger and loses its sharpness. The edges become less defined, the penumbra widens, and the umbra shrinks. Lift your hand higher and the shadow contracts, tightening its outline. The edges sharpen, the umbra deepens, and the penumbra becomes narrower. This simple movement reveals a universal rule: the distance between object, light, and surface shapes the clarity of every shadow we see. This effect is not limited to the lamp and the table. It appears wherever light and shadow interact: on a wall, the ground, a face in sunlight. Take this understanding into the world around us. On a clear day, the sun, though enormous, is so distant that its rays fall almost parallel, creating well-defined shadows. The edge of a shadow from a lamppost or a child running in the park appears sharply etched against the pavement. Inside a reading lamp or a ceiling light sits much closer. Its light spreads out, overlapping and scattering as it meets objects. The shadows it casts are softer, edges more subtle, blending into the light. Even the same object can produce a hard-edged shadow outdoors and a gentle blur indoors. Think of eclipses. When the moon passes directly between Earth and the sun, it casts a dark umbra, creating a total eclipse for those in its path. Around this, the penumbra gives rise to a partial eclipse, a gentle dimming of daylight. The cosmic scale of these zones mirrors the same principles found with a lamp on your desk. Shadows obey geometry. They reveal the unseen structure of light, the shape of objects, and the space between them. Every crisp outline, every blurred edge, is a silent record of how light moves and bends around the forms in its path. The next time you see a shadow, sharp or soft, remember it is shaped as much by the source of light as by the object itself.